Prove that for even powers of sine, the integral from 0 to pi over 2 of sine to the power 2n x dx equals 1 times 3 times 5 times ellipsis times open 2n minus 1 close over 2 times 4 times 6 times ellipsis times 2n um, pi over 2. That would be times pi over 2. Use integration by parts to prove the reduction formula. The integral of open the natural log of x close to the power n dx equals x times open the natural log of x close to the power n minus n. The integral of open the natural log of x close to the power n minus 1 dx. The integral of x to the power n times e to the power x dx equals x to the power n times e to the power x minus n times the integral of x to the power n minus 1 times e to the power x dx. The integral of tangent to the power n of x dx equals tangent to the power n minus 1 x over n minus 1 minus the integral of tangent to the power n minus 2 times x dx times open n not equal to 1 close. The integral of secant to the power n x dx equals tangent secant to the power n minus 2x over n minus 1 plus n minus 2 over n minus 1. The integral of secant to the power n minus 2 times x dx open n not equal to 1 close. Use exercise 51 to find the natural log. Restarting that. Use exercise 51 to find the integral of the natural log of x factor cubed dx. That was number 55. Number 51 was the integral of open the natural log of x close to the power n dx equals x times open the natural log of x close to the power n minus n. The integral of open the natural log of x close to the power n minus 1 dx. Number 56, use exercise 52 to find the integral of x to the fourth power times e to the power x dx. Number 52 was the integral of x to the power n times e to the power x dx equals x to the power n times e to the power x minus n. The integral of x to the power n minus 1 times e to the power x dx. Find the area of the region bounded by the given curves. Y equals x squared. the natural log of x, y equals 4 the natural log of x. And the next problem, y equals x squared times e to the power negative x, and y equals x times e to the power negative x. Use a graph to find approximate x coordinates of the point of intersection of the given curves. Then find approximately the area of the region bounded by the curves. Y equals arcsine of 1/2 x. Y equals 2 minus x squared. Y equals x times the natural log of open x plus 1 close. Y equals 3x minus x squared. Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the curves about the given axis. Y equals cosine of open pi x over 2 close. Y equals 0, where x is greater than or equal to 0 but less than or equal to 1, about the y-axis. Y equals e to the power x. Y equals e to the power negative x. X equals 1 about the y-axis. Y equals e to the power negative x. Y equals 0. X equals negative 1. X equals 0 about x equals 1. The next problem is y equals e to the power x. X equals 0. Y equals 3 about the x-axis. Calculate the volume generated by rotating the region bounded by the curves. Y equals the natural log of x. Y equals 0 and x equals 2 about each axis. Part A, the y-axis. Part B, the x-axis. Calculate the average value of f of x equals x times secant squared x on the interval open bracket 0 and pi over 4 close bracket. The Fresnel function big S of x equals the integral from 0 to x of sine of 1/2 pi t squared dt was discussed in example 5.3.3 and is used extensively in the theory of optics. Find big S of x dx. Your answer will involve the Fresnel function big S of x.